Hey guys, welcome to RC Video Reviews. Today we're taking a look at a power supply. I bought this just recently after doing some research because, I've been using a different power supply for quite a long time and it served me very well. But from time to time, I just want more current. And the one that I had a limit of 100 watts on AC. This one is 300 watts on AC. So that made a pretty big difference for me. And then the other thing was I wanted the regulation to go all the way down to something below 5 volts. So if I wanted to do benchtop testing for devices that require low voltage like 5 volts, I'd be able to do that. So today, the big problem with these is you can find these all over the place. It's not really magic to find these. They're readily available. I have a link in the description, of course, an affiliate link for this. And you can find them on Amazon fairly cheaply. But here's the problem I ran into pretty regularly was that a lot of them, they'll claim a certain wattage, like, for example, 300 watts. But when you read the comments from people who understand the nature of the math, they were saying, I'm not getting 300 watts. I get 150 or 110. It doesn't matter what load I put on it. I'm not getting there. So I once I got keyed into that idea, I thought, man, I'm going to check the comments. And I went through the comments and looked for people who responded in comments about hitting the wattage number. And this one, according to the comments that I read, hit 300 watts. Now, that said, I'm not suggesting this is the only power supply on Amazon that does 300 watts, okay? That's not what I'm suggesting. What I'm suggesting is that I went through to find one that did. And we'll test that. I'll show you that in just a minute. We're going to pop the cover off, and we're going to take a look at the electronics inside because I'd like you to see the quality of the work as well, because that's another issue that I've seen in comments with these kind of generic power supplies is that sometimes when you pull them apart, the quality of the work inside isn't so great. So I think we'll do that too, just to give you a look at what happens inside, and we'll give you a chance to look at the circuit board. And speaking of the circuit board, I hope you guys will allow me to get to the video in just a moment after we pay some bills. But first, for you electronics gurus and tinkerers out there, check out PCBWay.com. PCBWay has a full suite of services available to make your ideas a reality, including PCB manufacturing and assembly, CNC machining, 3D printing, and injection molding. When you're ready to order, PCBWay provides instant quotes, real-time production tracking, and you can order as few as 5 boards at a time, which is great for early-stage projects. If you need an experienced partner to help bring your ideas to life, check out PCBWay.com. I have a link in the description if you'd like to give them a look. All right, sorry about that. You know how it is, though. You got to pay the bills, and I appreciate PCBWay. They've been a good sponsor for the channel, and they allow me to, they help contribute to these types of efforts. So with that out of the way, let's get into the material. I've already removed the cover. I kind of did that during the break while you guys were listening to PCBWay, and I took the cover off. There are 4 screws on each side to take the cover off. And I wish that I knew enough about electronics to walk you through what everything does, but unfortunately I'm not an electrician. So all I can do is just kind of give you a little view of what's happening inside, and we can take a look at how things are arranged and whether or not we see a decent quality assembly. And that's really all I'm trying to accomplish here, is give you a look inside and let you determine for yourself if you think what you see qualifies or constitutes a quality build. I can say that looking at the solder joints, one of the things I pay attention to are cold solder joints. So, when you're looking at solder, for those in the Empire, when you're looking at solder joints, what you're looking for are shiny connections. You don't want to see a dull connection. That's bad. A dull solder joint, that's bad. That's indicating a cold solder joint. So I don't see anything like that in here. Everything looks like it was machine done, obviously not done by hand. So the solder joints look good to me. The components are rigid. I don't see anything sloppy or kind of floating around. I want to be careful what I touch because it was powered on not too long ago, and I know those caps will hold some power. There's a ribbon cable holding the front panel on. I did check continuity on the front. There's you have negative and ground. I did check continuity on the ground pin to ground on the back, and it does exist. So there's definitely continuity to ground, in case you're wondering about that. And then on the back, it looks like this is kind of a current shunt. I think that has something to do with current management. So those are probably devices that help with that. Notice how they're kind of attached or affixed to this back plate, and I'm pretty sure those are resistors, but I'm not 100% sure. Again, not an electrician, so I'm just trying to give you a look so you can see how it's made inside. I really don't see anything inside this case. It looks alarming to me. It looks well assembled. Doesn't look like it's going anywhere. And then when you put the case on top, and I'll zoom out just a little bit so you can see how that works. But when you put the cover back over the top, it really kind of stitches everything together and makes it very solid and firm. So with that out of the way, I'm just going to go ahead and put the cover back on. We're going to pop a screw in, a couple of screws, because while I work with it, I don't want to have something short out on me. So I am going to just put a couple screws. You have to be patient with me while you do that. So while I kind of briefly reassemble this case, a couple things I want to tell you that I was looking for. For me, what I needed was I want the ability on the bench from time to time, and I use these power supplies on the bench all the time. What I wanted was the ability to charge a 6-cell 5000 battery at 1C, so 5 amps. And then I wanted to say, well, if I'm doing that, what if I want to do 2? And that's where the 300 amp thing came from, because this is a 30 volt power supply and good for 10 amps. So you do the math and that comes out to 300 watts, right? So that was one of my requirements, was to do minimally I can't seem to get that one in there. So we'll just skip it and move on to the back here. So minimally, I wanted to do a 25 volt battery at 5 amps. So that's 125. And that's where I was having issues with my prior power supply on AC. I just couldn't deliver that. And then the other thing I wanted on this device, because I actually use this all the time, and I'll show you how that works too in just a moment. And that was a USB plug up front. I like the ability, if I'm going to put a desktop charger on my desk, I like the ability to have a USB charger in there. So overnight, or while I'm working on the desk, if I have something that needs to be powered by USB, I've got it right there in front of me. So those were kind of like the two major things. And then in addition to that, the other thing I looked for real quickly was I wanted a voltage range that allowed me to go down to fairly low voltage, so down below 5 volts. And then the reason I want to go up to 30 is because if you can go up to 30 volts, then you don't have to worry about boosting voltage in your charger if you're charging, say, a 6-cell battery. Okay, so everything is back together again. I'm going to switch back over to the side camera, and I'll give you a little tour of the operations of this device. To start out with, and before I do that, so again, requirements, 300 watts, up to 10 amps, up to 30 volts. 30 volts, 10 amps, those are a little bit harder to find. But the 300 watts was a big deal, and I wanted USB, and I wanted granular voltage control. So those were the big ones for me. Generally, when I use a bench power supply, I don't really govern the amperage. I don't turn it down too low, because I'm not using it to try and govern a short circuit or anything like that. I'm simply using it to provide amperage to a charger. So normally I'll just leave this pegged at 10 and just leave it sit there like that. So there's 10 amps configured. And then on the other thing on the panel is the voltage knob. So this is fairly easy to dial around. You just press the button until it highlights the digit you want to manipulate. So let's say I want to manipulate the ones place. So I leave it set there on the 2. And now when I dial this down, I can change the voltage at 1 volt at a time. So the voltage knob, very easy to manage that. Same thing with the amperage. You can set the amperage right there on the tenths place and then dial it down that way. Or if you want, you can set it over here on the ones place. Come on, ones. There it is. You can set it on the ones place and then manipulate it that way. And then after it stops blinking, that dial will continue to manage that spot. So if you want to turn the current up by 1 amp at a time, you can do that. And likewise, if I want to turn the voltage up 1 volt at a time, I can do that. I don't know why that skipped. It normally should stay on that ones place because that's where I left it. So I'll just press that again. We'll see if we can get that ones to cycle through, because I think that's where I left it. Maybe not. Maybe that's what happened. I skipped through it. There we go. So there's the ones place. Now I can manipulate the voltage 1 volt at a time. So nice and handy. And so for the voltage range, we'll go all the way down. It goes down to 1 volt. It might even do a 0.5 volt. I think I tried a 0.5 volt, and I think it did actually measure that. So we'll go and do a 0.5 volt, and we'll see. We'll see if it does 0.1, 0.2. Yeah, so there you go. 0.5 volts. And if I turn that on, it'll come on. We'll measure that in just a minute. I'll give you a look at that as well. So anyway, on the bottom, there's an output button and then a power button that shuts the whole thing on and off. And then a 5 volt, 2 amp USB charger. What I'll do on that is I'm going to give you a look at how all this stuff works. And we're going to measure it too so you can see it. So what I've got, I pulled out an iPad because an iPad can be hungry, and that's USB. Let's see, can I show you? That's USB-C on the bottom of the iPad. So I'm going to plug the iPad in, and then I'll let you just get a look at the USB-C, the USB charger, not USB-C. Unfortunately, my little tester, the screen only works on the top. So what I have to do is plug it in and then flip the unit over. And then when I flip the unit over, you can see the test screen. So I'll go back to the overhead camera. There we go. So there's my little USB tester, and I'll just plug that into the iPad, and you'll be able to see that one climb. There's 4 volts and 0.75. I needed to grab my pointer. I know. Don't say it. So there's 4.3 volts and 0.75 amps charging on the iPad. So USB works just fine. I have plugged in, obviously, the Radio Master, and of course that works. You can charge your phone, whatever, doesn't matter. So USB works. They claim up to 2 amps, 5 volts, 2 amps. I haven't seen anything pulling that hard on it yet. Maybe if my iPad were a little lower, it's like 99%, maybe it would pull a little harder. But they say it's capable of delivering up to 2 amps, which seems probably okay. All right, next thing I want to do is get the... in the box, I'm going to show you really quick what comes in the box. Obviously, you get the charger and you get the cable. That's a standard PC 3-pin power supply cable. And then they give you a little set of test leads. So these are banana plugs with alligator clips on the back, and you can plug those in and use those. I've had some of my own stuff, so that just goes in my stash, to be honest with you. All right, so that's what you get in the box. Now let's take a look at the voltage. So I want to set the voltmeter up real quick for you and give you a look at what's going on there. This is my Fluke. This is my reference meter, and I've had people on the past tell me how terrible consumer gear is, but you know what? This is what I've got, and I trust it. It hasn't let me down yet, so I'm just going to plug the voltmeter in on the power supply right there. I just put my test leads in there. We'll turn the voltmeter on, and we should have output. So I have it set for 0.05 volts right now, and there's the 0.05, and it looks like we're seeing 0.07 on the voltmeter. Let's see what happens when we lift the voltage up just a little bit. So I'm going to set the 0.5 just because my OCD says to do it. I'm going to set the 0.5 back down to 0 if I can. There we go. We'll set that back down to 0, and then we'll just bring the voltage up 1 volt at a time. So there's 1 volt, and you can see we've got 1.02 on the Fluke, and then we'll bring it up to 2 volts. I'm going to make sure I've got a clean connection too, because that can actually cause problems. You get a little voltage drop. Okay, so there's 2 volts on the power supply, and I'm seeing 2.02 on the Fluke. Let's bring it up. I won't stop at every step. We'll just bring it up to 10 and see how that does. So at 10, that looks pretty clean. At 10.01 volts, I'm liking that. And we'll bring it up to 20. So there's 20 volts. That's pretty close. I mean, the margin of error is getting really small at this point. Now we'll bring it all the way up to 30. We'll see what happens there. 29.999, 30, there's 30. So I'm going to say that's pretty good. I'm pretty good. Robert says, I'm having problems because I'm using my left hand. And that is the peak, although the meter will go up to 32 on the screen, and it shows that on the Fluke as well, and that's where it stops. You can keep dialing it up from there, but it won't go any higher. So 32 is about as high as it goes. And so that's that. So 30 volts, I like that. And I like it going down to, 1 or 2 volts. And the reason I like that is the next step. I'll show you that, and I'll show you that next. We'll set it. We'll go ahead and set it at 5 volts and leave it there. Now here's when I say, I said in the thumbnail, I like this because it does all the things. This is part of the reason I say it does all the things, and one of the things I like so much about it. So let's say on the bench, this is a very handy thing to have because it's easy to get a BEC and a battery and plug it in and do your thing. But if you're working on something that's going to be powered on for some period of time, this is a really cool little arrangement. Let me walk you through it. So I've got my banana plugs. These are going to go into the front of the power supply. I've got an XT60 that I put in line because that lets me change what I have connected to the power supply. So I use a little XT60. And then on the other end, I have some alligator clips that I use connected to different servo leads. So I have a servo extension if I want to use that. And I have a standard servo lead like you plug into any electronics device we use in the hobby, okay? And then here I've got a receiver. This is a FlySky IA6B connected to a basic servo. So if you're on the bench and you're testing, maybe you want to bind something up, you want to bind up a receiver, you want to do some servo testing, these things are really great for that because you just set it at 5 volts and then you plug that into your receiver. I'll just plug this into any port on the receiver, and I need to turn the radio on so we get a signal. And I'm just going to slide this back a little bit, give myself a little room, and then I'll turn the side camera on because I think that'll give you a better look at what's happening. All right, so I've got my receiver connected and it's bound. You see the bind light right there. So bench testing, and now I can just move my radio stick and you can see the servo moving back and forth. So for bench testing, this kind of thing is really, really nice. Another thing that you might think about that might require some bench testing is what if you have a receiver that says it can support up to 8 volts? You know, if you are using a receiver, and this one does, this one says 8.4 volts DC. Let me get you the big camera so you can see it. So 8.4 volts DC, but I don't think these servos will support 8.4 volts, so I'm not willing to test it. I don't want to blow up the servo. But if you are testing some higher voltage applications, we can simply take the servo off. I can take that off and then I can dial this voltage up a little bit just to see, you know, what happens if I go to 8 volts. Do I see any problems? You know, do I have any smoke coming out? Is there anything letting go on the receiver? And that's what I like about these things. They let you... What I like about this one specifically is it lets me use voltage all the way down from 1 up to 30. So the one thing I'll caution you on, and I have learned this lesson when you're using these, make sure you set that voltage before you plug in. Because if you have that set at 30 volts and you plug your device in, guess what? Poof, it's going to be gone. There's no mercy for it. So just be aware of that. Make sure you keep an eye on that voltage. All right, so there's 8 volts going into the FlySky. That's cool. I'm going to turn it back. Whoops, it went a little high there. We'll turn it down to 5 volts. And we'll unplug it. So there's the bench testing, and that's what I mean about it does all the things, right? That's kind of a big one for me, and that's really what I use these for all the time. I'm constantly using these types of power supplies right there for this type of bench testing where I can plug things in, bind, you know, maybe bring up a ELRS website on a receiver or a transmitter. It's that kind of thing. And that's where these things come in very, very handy, very helpful for that. All right, the next thing I told you, we have to torture test it. You know, that's the way we do things here. I need to see that this device can produce the 300 watts. So I've got some gear out here on the table. I'm just gonna go ahead and set this up real quick, move all my electronics test gear out of there, and I'm gonna plug in this charger that I've got. And I'm using a Toolkit RC M9 multi-charger, and I'll give you the overhead view so you can see what's going on. So here's the overhead view. Now what I've done is I've got the charger right here, the M9, and that is plugged in via one of these cables to the power supply. And I've got 2 batteries in parallel. So these are 6L5000. So I'm going to back this up so you can see the batteries. So the batteries are connected in parallel via a parallel board to the charger. Now, every single time I mention something about parallel charging, somebody comes in and says, parallel charging is going to say, I don't care. I'm just going to delete those comments. I've been parallel charging forever and never, ever had a problem with it. You have to be careful and pay attention to what you're doing, but never had a problem with it. Okay, so the reason I set this up is because this gives me the ability to kind of punish the charger or the power supply and put some load on it. So I'm going to start a charge with this one, and I'm going to set the charge current, as you can see on the screen right there. Charge current is set to 10 amps, and I'm going to set this, I'm going to put it off storage and put it on just regular charge mode. So there we go. Charge mode, so charge mode is charge. The end voltage 4.05, I'm just testing, that's fine. And the charge current is 10 amps. All right, so can you guys see that? There we go, 10 amps. So I'll switch over to the side camera. That'll give you a little bit of a better look at this thing when we turn this on. So we'll turn on the charger now. So that's our parallel connection for 2 6L5000s. And I'm gonna hit start. Oops, 10 amps. Sorry guys, I have to see it here. Oh, input voltage is too low. Nice, so that's the alert. By the way, if you're gonna charge at these high ratings, you may as well just crank the voltage up. This particular charger is good for 35 volts. So the higher your voltage, the less amperage you need to deliver. So I'm going to go ahead and set that at 30, and now we should be able to get it started. And there we go. We'll just watch that climb up, and you'll be able to see the number on both the charger. We'll see the amperage on the charger, and we'll see the amperage on the power supply. Now, I'll tell you guys that the power supply, oh, you know what? I have the current limited to 5 amps, so we need to bring it up. That's what I did wrong on this. Hold on. Did I have it set to 10 amps? Let's bring it up to 10 amps. There we go. Let's try it again. Operator error. I was wondering why the voltage was tanking so much. It shouldn't. There we go. That's better. That's more like it. That's what I expected to see. I was wondering why the heck the voltage was tanking on me. It's because I had the amperage set too low. All right, so there we go. You can see now the charger, we're hitting 10 amps on the charger, no problem. We're seeing a little bit less than that here because we're delivering 30 volts. So remember, the formula is volts times amps equals watts. So you can see on this one, we're hitting 240 watts. If I were to bring the voltage down to, say, 23, that would get us closer to 300 watts. So let's do that. We'll bring the voltage down to 23. And we'll see that we should see the wattage increase, and the amperage should go up a little bit too. I don't think the wattage will hit until we see 25. I don't think the wattage will come all the way up. So there we go. There's our 10 amps. So you can see we've got 9.7 times 23 volts. That's giving us a real close reading to what we see on the charger. So 9.2 amps on the charger. 23.4 volts. I've got that just a little low. Maybe we should make that 24. And there we go. So it's not quite 10. It looks like it's just a little shy, but I've been monkeying with it too. I'd like to see that peg out at 10 and just hold. So I'm seeing a little bit of fluctuation there. That should really hold at 10 amps, but it's close. That's close enough for me. I'm not, that's not disturbing to me. I can actually live with that. So there we go. There's our 230 watts. We're seeing 9.6 amps, 24 volts, and no problem. I've got 2 batteries, 2 6L5000s charging in this arrangement. So this is what I mean about does all the things, right? We have, on one hand, we've got a power supply that has got sensitivity values low enough for us to test things like bench electronics, like our receivers. No problems there. We've got enough power in this guy to deliver some pretty decent current. That's enough for me on the bench. 5 amps is enough. 10 amps is just proving a point. So we've got enough power on the bench to charge some pretty hefty batteries, and everything seems to be running along just swimmingly. I'm not seeing any real issues here. The charger seems to be happy. The power supply seems to be happy, and this is AC power. So there you go. I'm going to take a look at comments real quick and see if there's anything that you guys would like to see. That's one of the reasons I like to do these on live stream versus a production video, because it gives you a chance to interact, right? To ask me questions. And if I can, I'll try and show you, if I can answer. So if you have any questions, get them in the chat and I'll take a look, and I'll bring the chat up and let's go through the comments and see what you guys are thinking about. So let's see. Normal people use the right hand, says Freddie or Robert. Thanks, Robert. Appreciate you. How much is this? I missed it. Right now on Amazon, if you look at my affiliate link in the description, they have it for $62, but they have 10% off. So you're under $60. I think I paid $54 delivered. So pretty good. David asks if I can test Ripple. David, unfortunately, I'm not that smart. So I don't think I have a scope or anything to test Ripple. If you can tell me how to set it on this, if you can tell me how to set Ripple on this power supply, on this fluke meter, I'd be happy to try it, but I'm not that smart. So let's see. Robert, Martin would say, let's see smoke. Yeah, Martin would say that, but that's not going to happen today. Jeff says, would it be better to reverse the polarity of the XT60 connector with banana plugs? I don't know why. I don't know why you'd say that, Jeff. I don't know. reverse the polarity with banana plugs. Should have said reverse the male to female. Maybe. I guess if you're, I don't know. Maybe if you're looking to be safe, I guess. Maybe. I don't know. I've been using it this way for quite a long time without any real issues, so I'm not sure. It seems to be okay. Parallel charging is unsafe. Tim, that's 5 demerits for you, my friend. We're going to see you on Discord later. 5 demerit. Parallel charging is great. I know, right? Man, I use parallel charging all the time. I've been using it for a very long time, and I have no fear. Parallel charging is nice. Is just fine. Somebody in Russian spoke in Russian. I can't translate that, so buddy, you're going to have to hit me in English. Go to Google Translate, give it to me in English, and I'll do my best to answer it. Bill says, nice device, pretty slick. Yeah, I think so, Bill. And again, like I said, it's not It's not like I had an issue finding devices on Amazon that were able to do 300 watts or that claim 300 watts. That wasn't the issue, right? That it was clearly they're out there. What I did have a problem finding, though, were devices that would support up to 300 watts. There were a lot of comments in these device sections that said, man, mine only does 150 or it only does 120. And they were talking like, you know, they understood what was going on. You know, it's just one of those deals. So yeah, I think it's a nice device. Feedback on fan noise. I don't think I can get a mic behind it, but I do hear the fan. Let me see if I can pull that forward for you. Hold on. That's a good question. The fan is going, but you know, keep in mind, I'm also drawing 10 amps. I can tell you at low voltage and low current, almost no fan noise at all. I don't hear anything at all. Right. And the fan just stopped. So it just stopped and it's still at 9.7 amps. So it seems reasonable. How about that? I mean, if we're in a steady state charge at 10 amps, the fan comes on, cools things down and shuts off. Not too bad. I have to remove my headphones to listen to it. I would say that the fan on this is no quieter than the fan on this. How's that? I mean, this one's got a fan that's blowing right now and it's no quieter than this one. This one sounds bigger. This one sounds smaller but faster, if that makes sense. All right. Sorry, bud. No Russian translator yet. Can't help on that. This is going on my bench. Missed the start. What is the green ground? That's in case if you need a ground, it is that green ground is a ground circuit. So that goes to ground on your AC supply in the back. So if you need ground, you have it. So it looks like a battery. So it looks the same as a battery. I guess you're talking about my little joiners in here. Where are these? You're asking about these, Jeff? Well, I mean, I guess the way I would look at it is the way I have this set up right now. Let me bring the top in. I mean, this is going to be 6 of one, half dozen the other, but this one I don't know. I guess you could reverse it. That'd be fine if you wanted to. You know, if you wanted this to be the one coming from your battery, just like, you know, because that's where your power comes from and this is where your load comes from, right? I guess that's what you're saying. I guess that'd be fine. I never really thought about it. I just built all mine this way and it works. I just don't see an issue with it. It's fine. But, you know, it's whatever makes you happy. You know, if it works for you, go ahead. Let's see. Mike Sherwood says, Amazon flat out, no Prime at 69. I bought the white version. Oh, yeah, that's true. I am on Prime. And so on my listing, it showed up as $62. So 62 plus 10% off. So I got it for like $54 ship. Put a knock to it in it. Yeah, I might do that at some point if it gets to the point where it bothers me. But you know, when I'm working on this, like this stuff on the bench, I don't care. And I could do a 5 amp test. In fact, I'll do that while we're talking. I'll lower it to 5 amps. Let me just bring the current down. I'm just going to bring the current down to 5 amps. And while we wrap up the questions, I'll see if the fan quiets down at 5 amps. I can tell you that in my bench testing for the devices, the electrical devices, no fan noise at all. It never blew. And there we go, down to 5 amps. Oh, one other thing about this one that I like too that I didn't mention because it's kind of subjective. I mean, it is kind of subjective at the end, but a lot of these devices that we see, the generic, you know, they're generic Chinese manufacturer devices. They use some really goofy colors, like, you know, green and white and you know, all kinds of color down here and some turquoise. I mean, I've seen some of these things that just the design was just awful. One thing I really like about this one is it's a very elegant looking design. It's a simple, nice interface. The knobs aren't crazy colors. I don't mind that the LED, it's a bright white. I can see it it's broad daylight in here. I've got a great big spotlight on that thing right now, and I can see it just as plain as I need to. So I like the white LEDs. The font is nice and big, and you can see the numbers, and it shows you there's a red dot here that's CV, and this one over here is CC. So if it's switching between constant current and constant voltage, you'll see that there. And the controls are just easy to reach and operate. So one thing I did do, and I'll show you while we're charging, because I have it on a desk. Let me pop this. Let me pop the top camera on so you can see it. I did add these little rubber stickies to the bottom because the rubber feet they had on it, it slid around on the desk. But when I added these little rubber feet from Amazon, it stopped sliding. So now I can press the buttons without any issues. So I did add that. But as far as the appearance goes, I know it's subjective, guys. Don't criticize me for that. But I like things to look a certain way, and for me, it blends in on my desk really well. So I like the appearance of this one too. It doesn't look comical like a comic book box of crayons threw up on it. It looks like a professional device. So very good. Oh, I saved this for you guys too, and I forgot. I saved this for you guys. Here we go. Let's have a little moment. You guys know this is the best part of electronics, right? Is peeling the protective screen off. And of course the tape came off instead. Can you believe that? What a letdown. All right, now I got to hold the plastic. Here we go. There we go. We'll peel this bad boy off. Oh, I love removing the protective screen off of glass. There we go. That's better. Now we have a nice clean interface up front. So yeah, I like the way it looks. No problems there. I usually worry if I can't hear the fan. Yeah, that's also a thing. Robert's not wrong. If you're running high amperage and you don't have any fan at all, yeah, that can be a problem, right? Test leads don't look very robust. I don't know which ones you're talking about. You're talking about these? These aren't the ones that came with it. These are just generic banana plugs that I bought off Amazon. I've got a stack of them. The ones that came with it, they're right here. I don't know. Are they supposed to look more robust than that? They look okay to me. I didn't have a problem with it. All right. How's it going? Use hot glue bubbles on the bottom. Ooh, protect the table. That's a good idea. Hot glue bubbles on the bottom. I like that. Colors. That's funny, John, says the guy with a putrid color transmitter. Hey, Robert, don't stop picking on Precious, man. She's not even here. All I heard was Robert needs to see Precious. Oh boy, it's not going on my bench. Amazon Sweden don't have it, but I will get something similar. Yeah, Tobias, just do yourself a favor and check the comments for the wattage. That was the one big thing that I wanted to make sure that it produced, was the wattage that it said it would produce. And I can tell you guys right now, I turned the amperage down and I really don't see, the fan is barely, it's moving, but it's really, really quiet. So it's a variable speed fan out of the back, and I can barely feel airflow coming out of the back right now. So it feels okay. And it's very quiet, so I don't really hear anything. Have you tried the output button? Yeah, the output button is what turns your voltage on and off. So if I press the output button, that will turn off. You'll see it. The charger's going to complain. We'll turn it off. But when you do that, that's it. That kills the main port disconnected. That turns off the output. That's what that does. So when you turn that back on, that applies voltage to the device. So that's what the output button is for. Maybe you knew that. I don't know. Maybe you were just asking me to show people. I'm not sure. All right. All right, that's about it. So we're up and down on this. It's a I don't even know what that's called. Icocator, Icocator DC power. It's a generic name. It's not a brand name, but seems to be doing the job fine. I will. You stick around on the channel. And feel free to ask me. At some point later on down the road, I'll be happy to tell you. What's going on with it and what I think of it over time. If you want to ask. But we'll keep this on the bench. And oh, that's one other thing I thought I might do for you guys to help you out. Let's just disconnect all this stuff and set it aside. And I wanted to give you some measurements too, so you could get an idea. I don't have a measuring stick handy. I don't have a ruler handy. But what I can do that is handy is I can show you things that you'll be familiar with. So if you're familiar with a TX16S, there you go. There's the length of the device. Can you guys see that okay? Lengthwise. So I don't know what a TX16S is, but hold on. Let's just measure it the right way. Give me a second. I'll get a measuring stick. That was kind of half-baked, wasn't it? All right, here we go. All right, so it's a long measuring stick here. 220 millimeters long. So I have it set right there on the edge at 300, and it goes to 520. So 220 millimeters long. And then widthwise, stand it up. Take a measure of the width. We are at about 80 millimeters wide, and height, We're looking at about 145 millimeters tall, give or take. So those are the dimensions in case you're interested in the size. I did want to make sure you guys got to look at dimensions too, because that's another thing that on some of these, it's really hard to understand just how big or small these units are. So there it is. And then I'll put the Radiomaster TX16S next to it. That'll give you a pretty good look. So you get an idea size-wise for something you're familiar with, what you're looking at in terms of size. Can you see it? There we go. There we go. Now you get a pretty good idea. All right, let's see. I'll check and see if there are any other questions. And then, have you tried the output button? Got that. Tobias, check on Amazon. Has different names, different colors, same one. You say Precious. How much does it weigh, says Robert. You really want to know? Robert's messing with me, but he thinks I don't have my scale nearby. So joke's on you, buddy. Hold on. Let's take the side cam off. We'll go back over the top. And Robert wants to know how much it weighs. Like I wouldn't be prepared for that question. 1249. That's less than the batteries that I just bought for the jet. I'm guessing you took it apart for yeah, earlier in the video, Michael, I took it apart. We opened it up. Again, I'm not an electrician, so it wasn't like I could give you a walking tour of what every element was. We were just kind of looking for completeness and, making sure the soldering wasn't bodged and the, wires were secure inside and all that stuff. And it looked good. It looked like it was quality work. I didn't see a problem. So there we go. That's the iCococator power supply, the generic power supply. I hope you guys liked the video and found it informative. All I can say is it seems to be a very versatile device for low voltage, high voltage, up to 30 volts, 10 amps. Very wide range of applicability for things that we do in the hobby. And for me, I can tell you, as long as it survives and works over time, I think, based on what I've seen so far in my initial assessment, is that I should be pretty happy with this one over time. It'll just sit right there next to that lamp right over there on the desk, and it'll be ready for any kind of work that I want to throw at it. Where's the pointer? I got the pointer right there. I got the pointer. I had it ready to go. All right, guys, listen, I hope you enjoyed the video. If you want one of these, check out my affiliate link in the description. I did do the homework to make sure I got one that supported the wattage it claimed. So that's why I did it, and that's why I thought we'd do the video. And also thanks again to PCBWay for sponsoring the video. I appreciate their patronage of the channel. They are helping me do things like this. It just helps. Every bit helps, right? You pretty much nailed it on the head. Great review. Thanks, Robert. I appreciate you, man. I hope you guys found it informative and useful. All right, that's all I've got for today. If you like this kind of material, make sure you hit that thumbs up, subscribe, and hit the notification bell so you know when new videos hit the channel. And that's all I've got for today. Get out there and fly something. Take it easy.